Good day, computer app students. In this video, we're going to talk about how we can take that 2D data we've read in using Xarray and plot it up on a map using contours and color fills. And so to begin, you may want to start a new notebook, copy and paste over the initial import statements that we've used from previous notebooks in this series. But we need to add a few more things in. So this is the classic set that we have been using. But we have a couple more. If we're going to want to plot on maps, we're going to need some new modules to use. And so we're going to import from Cartopy, which is the current mapping du jour module, one of their modules called CRS, which is short for Coordinate Reference System. And we're going to call that as CCRS to be able to reference that within our program. Additionally, we're going to bring in import Cartopy.feature as CFeature. Whoops, I mistyped Cartopy. And so these two modules, or parts of the Cartopy module rather, are going to help us plot some things on the map. We are also going to maybe just use a brief bit of calculation here with our 2D data. And so we're going to say import netpy.calc module as mpcalc. So we'll get that in. All right, and we're going to switch up what data set we're using. And so we're going to go back to this lecture number 13 in the Python framework. Scroll back up here to our NCEI data and click on our link to get to a different thread server. Here we're going to want to use the grid 4 analysis set. And we are going to go ahead and use the historical files, which are files that are older than about the past 3 months. So we click on that, and we see we have data that actually, if we scroll all the way to the bottom, goes back to 2004 sometime. But we're going to take some data from last October 2019. And let's go ahead and take Halloween of 2019, and that we want to find the 12 UTC file from 2019. And so that's this grib2 file. And so if we click on this file, we get back to this kind of threads data access page. And we see, again, we have this opened app access. Let's click on that link to then get to the data URL that we need. We're going to go ahead and copy and paste that data URL. Come back over to our 15 one here. Just going to put some quote marks in here and save that off. We can either go back and copy or just rewrite. We know we're going to have dataset ds equals xr dot open underscore dataset, open parentheses, Python trying to help us out by giving us 2 already, and then getting the final parentheses there as well. Now, we could make this a little more accessible to us by splitting this up into 2 lines. And theoretically, this same structure is going to work for nearly any file, right, that is in the older data set back to when the data started, such that we could use the date time function that we might set up to say populate the year month day, the year month day, and the hour here in our file name. We're not going to do that here now, but it is something that you can do using fstrings. So let's go ahead and run it and gain access to that data file. And if we go ahead and type ds, we again see we have our very large data set with all the, with a whole bunch of different GFS data, but it's all going to be for a single time. We're going to go ahead and minimize that side part there. So it's great. So we got our data in, but before we go ahead and do that, now let's go ahead and think about how can we plot some things up. And so we're going to first plot just a map without any data on it to figure out how this works. And so the first thing we need to do is we actually need to set up something called the Coordinate Reference System for the map. And there are a bunch of different coordinate reference systems, and we can click on the scitools.org.uk to get the Cartopy documentation. Our Cartopy projection list is what we want to go to. And we can see all of these different projections that are available within Cartopy. We're going to start with just the most basic one, which is plate Curie, or plat Curie. This is basically saying I have lat-lon data and I just want to plot lat-lon data, right? As someone might say, French for lat-lon. And so what we want to do, we need to access it from the coordinate reference system of the Cartopy module. So that's that CCRS that we had coming in. Dot, and then plat Curie. Open, close, parentheses. And so we don't yet have a figure. We haven't set anything up, so that's why nothing is showing. But we've set up this coordinate reference system. It is set by default, going back to our documentation page, to be centered along the central longitude of 0.0, that prime meridian in the middle of the map. We could switch it up to be over the date line at minus 180 degrees or 180 degrees, depending on which way you're going around the globe. But we'll go ahead and leave it just with that central longitude as 0 longitude. And so we've created our initial figure instance here. But then we needed to find that axis that we want to plot on, just like we were doing with our mediograms and with our skew T plots, having this axis that we're plotting on. And so we can do this in one way by saying fig.add_subplot. And then we're just going to do one row, one column, figure 1. And here's the key thing for plotting on a map. We need to feed into matplotlib the projection of our map, which we've already saved off as our variable map CRS. And then in order to plot something on the maps on that axis, we're going to plot the coastlines. And so there's a method to plot basic coastlines on our plot. And lo and behold, look at that. We get our nice coastline plots of the whole globe being in the center there of our 0 degree longitude. Becomes pretty easy to switch up what map you might do, and so we could add a title if we wanted to. plt.title plate Curie map. Good old title there. We could then copy and paste, Control-C, Control-V, and say we wanted to do a different projection. We could scroll through, find one that we may like. Oh, how about this Robeson projection? Or Robinson projection, as one may say. All we need to do is put in this different value. And so instead of plate Curie, Robinson projection, it's going to feed into our map CRS variable, and now we will get our simple map in a Robinson projection, and we should maybe change our title to reflect that. And so there are many different projections that you can use. Some are better than others, depending on what the purpose is. And so that's part of what you get to choose as the map maker. One that we like to use for mid-latitudes is something called the Lambert conformal map. And so let's go ahead and copy and paste our basic plot here. Let's go ahead and back to our Cartopy, and let's find our Lambert conformal. So Lambert conformal has a whole bunch of keyword arguments that we could put in. Let's just copy and paste this idea of Lambert conformal. Control-C, Control-V. So we see we get this wide projection. We can specify some of the things about where we're centered, and so we can change that with our keyword arguments. Central underscore longitude equal minus 100. Central underscore latitude as equal to 40. We see that that made probably not terribly noticeable differences here. That's because our default, right, is the central longitude of minus 6 and a central latitude of 39, so it's really not all that different. But we are seeing this larger view. And so we can begin to work with our ways of plotting to narrow this view down. And so something we can do with our axes is we can set the extent. Set underscore extent. And then we have our x values and our y values. Here it's more amenable. We can use just our minus degrees east, so minus 40 to minus 55, from 20 latitude to 55 latitude. Now we need to specify that these are in geodetic coordinates or plate coordinates, either way. And we get a nice, much narrower view. And so we could be like, oh wow, we're just about to cut off Florida. Let's actually make this down to 15. And we get a little wider view. And while this is a fine map, we see that this isn't all the best resolution of the coastline. And so we can actually modify this line to do it in a different way. We could add a feature to our axis. And this is where we can use Cartopy features to help us out, which we can gain access from C feature and say we wanted to add the coastlines, .coastline with _scale. We want to use a finer resolution scale, so 50 meters. So notice between the map now and after we run the cell, we get a much more detailed map. There are other features we can add, like state borders here. Now, since we are in a closer view, state boundaries are something that we might want to plot. Now, you may have gotten some warnings about downloading some data. And the first time you run these, it will download some shapefile data to your local system. And so again, it's pretty easy to make a map, pretty easy to change things about the projection of that map, or how those maps look. But what are we really here to do today? We want to ultimately plot some data on our map. So the first thing we're going to need to do is we're going to need to go ahead and bring in some data. So let's go back to our 13 file here and find the temperature data that we want to bring in. Go ahead and copy this. Control C, Control V. Need to make this ds.temperature_isobaric. Using tab completion to help me out. Oh, we've already specified our date above, so we should all be good there. We're getting 850 data. We're slicing just over the US. Let's go ahead and convert that TM to temperature in Celsius equals our tmpk.metpi.convert_units. Again, units here really help us out. Then we don't have to do the math ourselves. And then let's pull out the v times. And so we'll say tmpc.time.values.asType date time 64 milliseconds .asType capital O. And now we've gained access to our data. And so let's go ahead and take a look. tmpc.shape is going to be just our 2D shape, right? We have 101 by 171. We'll go ahead and just print out tmpc. We see it's a full data array that has associated lat and lon values, as well as our time values. We already converted those time values. So the question is now, how do we plot this? How do we plot these values as contours so that we can get a plot that we're used to looking at? Let's go ahead and copy and paste our Lambert conformal map. Since we're plotting the mid-latitudes, let's plot something using the mid-latitudes. And let's initially run this to make sure we have our full system here. Let's make a bigger image. Let's do 17 by 11. So we're going to get a little bigger image. You'll see a little bit more detail then. But now we actually need to add contours. And so matplotlib has contouring in two different ways. We can contour, or we can color fill our contours, or basically shade our contours, or we can show it as a raster image with this image show, IMShow functionality. There's actually even a fourth way called pcolormesh that you could look up as well. We're going to focus in this lecture on contouring and color filling our contours. And to begin, we're just going to do our contours. And you can click on these links or follow these links to get to that necessary information. But we want to go ahead and add to our axis contours. Contour. If I could spell today, that'd be great. Okay. And what do we need to do? Now, when we do our Shift Tab here, it's giving us this thing because we're going through Cartopy to do this. We're not getting all the information we need. But basically the format is we need our x variables, so tmpc.longitude, our y variables, tmpc.latitude, then our tmpc values for our, which are going to be our actual temperature values. And then we need to add one critical thing here, right? We need to add a transform, right? Because our data is in lat-lon format, not in Lambert conformal projection format. So we need to tell it ccrs.plate_Curie, tab completion there to help us out, because we are plotting with lat-lon, and so we need to transform that lat-lon so that it'll appear on our proper map coordinate reference system. So let's just run that and see what it looks like. And look at that. We get some nice data going on there. Okay, we've automatically done some coloring based on some default parameters, which may or may not be good. It looks like our view is a bit wide, so we can narrow that in maybe a little bit. Say minus 125 to minus 70. See how that looks. We're getting a much better look there. But now let's kick this lower bound back, maybe to 22. Wow, and we get a really nice map focused in on the US where we can maybe see some of the detail. But what are these contour values at, and can we maybe work a little bit with the range? So we can specify the next thing in our X, Y, and then our values, the Z values, if you will, which are our temperatures in this case. Then we want to go ahead and say we want to contour the range from minus 50 to 51 by 5. So every 5 degrees Celsius is the way we can do that. If we plot that up, it changes our contours a little bit, but we still don't know what the values are. We can say CS equals this whole thing, save it off as contours, CS short for contours. And then we can use another part of matplotlib to CLabel to label our contours, feed it that CS variable, right, that handle, and we can give it a particular format to be just integers, right, just the whole values, %d. And so if we do that, we then see we have, 10, minus 5, minus 5, minus 10. And so we see those contour label values periodically throughout our map. But man, I want these to be red contours. We could up here specify the argument colors equal red. And now we get red contours, and matplotlib will automatically, if we have positive and negative values, automatically do our line style as dashed for negative values. Just like our XY plots for time series data, we can specify these can be dashed, they can be dotted, they can be dot dashed. Again, you have a lot of choice over how these contours look, and I encourage you to look up the matplotlib information on contours to find out what some of those keyword arguments are. Here we just have a generic title of Lambert conformal map, but that's really not all we're plotting now. And so we may want to specify something more particular. Say we're plotting GFS, 850 HPA, temperature data in Celsius. That's great, but we also want to do temperature. We can actually specify multiple titles by specifying the location keyword. And so we're going to put this one on the left side of our plot, so we see it now all the way on the left. And then we can create a second title, plt.title. We're going to make this one an F string. We're going to say valid time. And put in our valid times argument, or v times rather, is what we called it. And our quote there. And then we're going to make this location on the right. Boom! There we go. Very, very nice. But what if we wanted to plot multiple things on one plot? Say we wanted to do heights and we wanted to do temperatures. Well, first thing we need to do is to bring in some heights. So let's go back to our first one here and bring in these heights. Copy. Paste, bring in our height values. We're now good to go there. Let's copy and paste here our map to start with what we've got. And now instead of contouring our temperatures, let's contour our heights. So change these to HGHT. Copy, paste. Now our range is going to have to change. Let's go from 0 to 10,000 by, and this is for an 850 map, so 30 meters. And we're going to make those black contours. And so we see there, quickly we get some really nice contours. So we're going to add in 850 heights in meters and temperature in C to change our title up. And so that's good. And now what we want to do is we want to create color fill plot maybe of our temperatures. And so let's go ahead and start with the contour, but now we're going to change this one into color fill. And that's contour F. We're going to want to plot all those same things. We're going to want to use the same range. But now we're going to want to change, instead of just colors, we're going to say our color map, our C map. And we're going to pick from Matplotlib, color maps. We're going to pick one that is cool, warm is the name of it. So let's plot that up and see what happens. Oh, look at that. We get a really nice plot where we can see these different temperatures associated with our different heights. But, that's not as refined of temperatures I might like since I'm doing color fill. So let's change this to every degree. Doing so is going to take longer to plot, but now we get a much more smooth looking plot, which may be advantageous to us. But we don't have a way of referencing what these colors are to temperatures. This is where we need to add a color bar. plt.colorbar of our CF handle, we're going to say pad equals 0. By default, this is going to put a color bar on the right-hand side of our plot. And we see that we've made it, that because of our transform and everything, it's just a little bit too big. So we're going to go ahead and change this into 18 by 11. That didn't help us out, so let's go to 16 by 11. We just need to play with this figure size to get our, okay, it looks like we need to actually go larger, 22 by 11, to get our color bar to snap to the edges of our frame. And so we see that there. We also have this little white space because we've gone a little bit too far to the east, so we can modify that just a little bit. Maybe we'll go to 71 instead. Narrowing that view just a little bit. There we go. Very nice. Now, this is great, but some of our lines are a bit squiggly. This is where we could use some functionality from MetPy's calculation module to smooth our values. So smooth TMPC. From mpcalc, we're going to use smooth underscore n underscore point. And then we're going to smooth our TMPC values. We're going to use a 9-point smoother and go through 2 passes. We can do the same thing with heights. Change up our variable name here to be HHT. HHT. And we're going to copy and paste, replacing our raw values with these smooth values. And we get a slightly refined look, right? It's a little smoother lines, but doesn't take out all the nuance, so that we get just this really nice map. We could get a lot more complicated with other things we can do. We can calculate other parameters to plot on plots, but that go beyond the scope of this particular unit, and so we'll have to seek further videos for that piece. That's it for this video. Thanks for watching.